So have you ever wondered how spacecraft actually get built? And who is the team that's actually responsible for making sure that everything on the vehicle is operating the way you want it to prior to getting it launched into space? Hello everyone, my name is Ty Ridings and I work as a systems integration and test engineer for a large aerospace company. And I wanted to take this chance to make my own video discussing my experience being an AI&T, which stands for Assembly, Integration, and Test, and give a little background on what I think most teams that go by this designation of I&T, AI&T, ATLO, whatever it is, and talk about what function that organizational piece actually offers to getting something into orbit or on its mission in space. Without further ado, let's go ahead and jump into today's topic. Okay, so for starters, what even is AI&T, or Assembly, Integration, and Test? You'll find if you've scoured the internet at all for jobs or stumbled upon a Wikipedia page wondering like where stuff actually gets built and who are the hardware test owners, you will find that there are many similar titles. You have Assembly, Integration, and Test, Integration and Test. You have people like me who are Systems Integration and Test. You have Assembly, Test, and Launch Operations, and many, many more acronyms that are basically discussing the same thing. Usually there are teams in most product life cycles that are responsible for putting together the space hardware and then testing to make sure that everything on that vehicle actually works. So thinking big picture for the role, it's connecting everything together and making sure that it all operates at the system level and is delivering on the promises that all of the engineers and the suppliers and the designers swore to when they took on their requirements from their customers. Something that I was wondering a lot early on, and maybe something that you're wondering too, is like, what is the difference between being an integration and test engineer versus a designer, or maybe just manufacturing engineer, or a systems engineer, or really any other engineer in the aerospace industry? Speaking from my own experience, it's kind of interesting because depending on where we at in the development life cycle or the test life cycle, you could be doing a lot of different things, from manufacturing engineering duties, building work instructions, and getting familiar with how to process and kit all of the hardware that can be used and consumed on the floor, to mechanical functions where you need to understand very basic mechanical principles of like stress, dynamic loading, environmental loads, structural capabilities, and the overall build quality of your product, to electrical concepts, basics of wiring and harness routing, to then different data types and data paths, along with a lot of software heavy work that needs to be done to make sure that all of your payload components are working together and that your overall build is communicating appropriately and able to perform its mission. The list goes on and on and on. For integration and test, you live your life split between being on the clean room floor, where actually hands-on with the hardware, building it, testing it, making sure that it actually is working in real life, to then being at the other side of the aisle where you are discussing your findings, you are coordinating across many different product teams to make sure that everything is getting delivered and working the way it's supposed to, and becoming sort of the belly button for the build and the build quality right before getting it delivered to your customer for mission operations. What are the things that you're actually testing for? The way my company handles our testing is an acronym TLYF, which means test like you fly. Basically, that means you want your vehicle to experience just about as much as it will see in flight as you possibly can while you're on the ground. This can be vibration testing, thermal testing, EMI, radiation testing, to then how it actually runs all of its communication paths. So these are different frequencies of radios, and then all the way down to like very basics of just making sure software versions are right, all of your mechanical hardware goes together properly and is not dysfunctional in any way. Same with your electrical hardware as well. Testing all of your copper paths and verifying that everything is operational at a very basic level. The overarching goal is to validate end-to-end functionality of your product and any adjoining systems that it has to work with, vetting that it is ready for flight. To get really specific about AI&T, my company operates in a hierarchy of roles that actually perform duties on the floors. I personally am a CTC, that stands for a certified test conductor, and all that means is I've taken a ton of training and taken a lot of on-the-job training as well under other board certified test conductors, showing that I'm capable of conducting a lot of the more critical operations that need to be performed on a daily basis and can be trusted with owning the hardware for a lot of that testing sequence. Below that, you have your test engineers, where I started out, and that is just someone that is going through the process of either becoming a CTC by doing their training and doing all of their practice working with spacecraft, before they get to owning and being the person in charge for those operations, or this is somebody that is just kind of filling in a role to carry out some of the more lower level tasking to get spacecraft ready for flight as well. Outside of that, you have your technicians. Now, technicians are pretty common in manufacturing and other parts of, the industry, but for us, they are truly the hands-on workforce that gets stuff built. For my mechanical team, we generate things called work instructions. This is where we get into that blend of manufacturing engineering, and in those work instructions, we are basically synthesizing our released engineering products. So for us, that's models, there's sometimes drawings, but anything that the engineering team releases for the build, we are translating that into instructions that tell the technicians and the technician team how to actually put all that stuff together and verify that it's in working order and built to the condition that was released in our engineering. So arguably technicians have one of the coolest jobs, which is coming in and like being the heaviest hands-on when it comes to actually nuts and bolts, wiring, and a lot of craftsmanship that goes into putting stuff together. So let's talk about a typical day in the life of an AI&T engineer. You're gonna hear me talk about something called the floor very frequently. And for anybody familiar with working inside of a clean room or a production area, the floor is the reference to the place where all of the magic happens when it comes to building and testing your products. That's where all of your hardware lives. That's where all of your test equipment lives to make sure that you can carry out the full build and the majority of the test cycle for your hardware all in one spot as much as possible. And I'll go into the caveats here in a little bit, but my team starts every day at 6:30 on the floor. We have a daily stand-up, and this just consists of kind of discussing what has happened either on the prior shift or the prior day. And then we go into tasking out every single CTC, test engineer, and technicians to make sure that every person knows what their job is starting immediately for the day. We break from our meeting and everyone takes off in their own work cells and begins prepping all of their tools, all of their documentation, and starts executing on the tasks that they received at the 6:30 stand-up. Speaking for myself personally, as like the test engineer role, your day can kind of fall into one of two areas, and that's either being on the floor or off the floor. If you're on the floor, your main priorities will be making sure the spacecraft is getting built to the work instructions and the engineering that is released for your product. So that's working with your techs and making sure they have everything they need, whether it's materials, tools, personnel, whatever, to kind of keep the ball moving forward with getting the build completed. On the electrical side of the house, you have whatever tests are being conducted for the day. Sometimes these are just simple health checks for your payloads. Sometimes it's more rigorous systems level testing to make sure like all of your RF paths are functioning. Other times it gets into heavier operations. So this could be things like deployments, where anything that is meant to move, you actually go through that simulation of moving said quantities of parts and assemblies to make sure that you are confident with the workmanship, not only at the system level, but at whatever supplier or vendor specific or even an internal build populated that product that gets put onto your spacecraft as well. If I'm being honest, probably the number one thing that test engineers are trying to do is see where things are breaking and then troubleshooting those anomalies to try and fix them as quickly as possible and make sure that it's not persistent, it's not something systemic, kind of poking any holes that we possibly can in the designs to make sure that they're robust enough to be ready for the customer to use. The other section of your life could be spent off the floor, and this is typically whenever we're getting ready for production or AI&T to start. There's a lot that goes into developing documents that you need to execute all of your testing. So for us, this starts with our master test plan or just your test plan. And this is where we author in the overarching sequence and environmental plans, our hierarchy of like test procedures, how we're gonna do the build, how we're gonna move all the vehicles around, really anything that's related to getting something built. Below that, we have a lot of test procedures that we have to create. So that's working with our responsible systems engineers to make sure that we are translating the top level requirements that we're held to, and we're baking those into procedures that we can execute on the floor. So the last piece of the day is your afternoon or your evening, where you kind of wrap up whatever you're doing for your shift. A big focus is making sure that all of our teams are closing on paperwork for the day so that the information that we are gathering, we were working to, or we were capturing for the day is not lost when you go home and have to come back and figure out where you were at. It involves cleaning up our clean rooms and our bays to make sure that all the tools are put away. And then general housekeeping, just walking around, making sure there's nothing out of place, there's no hazards that are being left for the next shift or the next set of personnel to come into, and ensuring all of your hardware is in a safe state as well. If you've been enjoying learning a little bit more about the strange world of spacecraft builds, you'll probably be just as keen to use a wonderful app called Brilliant that's kindly sponsored today's content. Brilliant is a super handy app that helps you get smarter every day with a vast library of interactive lessons in math, science, programming, data analysis, and very relevant topics like AI. Brilliant helps build your critical thinking skills through problem solving, not just memorizing. So while you're building real knowledge on specific topics, you'll also be becoming a better thinker. More importantly, Brilliant makes it easy to learn anywhere right on your phone. With fun, hands-on lessons you can do whenever you have time, whether you're diving into a new topic or doing a quick practice session, you can level up on the go in just minutes. I've recently started exploring their How AI Works content, and honestly, it's been really mind-blowing. Their simple and effective content paired with the bite-sized practice problems has given me a boost in understanding all of the cutting-edge methods being used around the globe to fully harness the power of artificial intelligence. So if you're interested in trying everything Brilliant has to offer free for 30 days, please visit brilliant.org/TaiWritings, or you can click on the link in the description. Further, Brilliant is offering an additional 20% off an annual premium subscription if you follow my custom links as well. And now let's get back to integrating and testing spacecraft. So maybe you're curious, like what do you need? What qualifications do you need to kind of go into this sort of career path if you're interested in it? The answer might surprise you. I think for education, it's pretty typical to have an engineering background, but I can't say that it's any one path. In my experience, I've seen aerospace engineers, I've seen electrical, mechanical, systems engineers, I've seen people with physics background, people with math backgrounds. There's really no gate as long as you're just willing to learn how to perform a lot of the testing duties and go through a lot of the on-the-job training that has kind of gotten cooked into the process I've experienced anyway. I can't really speak for other companies or other parts of the industry. Outside of just like formal education, there are some skills that I feel like are super important that I am constantly working on that I think are just worth mentioning overall. One of them is knowing just enough about a lot of different things. You are the touch point for so many teams that have their own stakes in this race to get your vehicle performing, whether that's software, hardware, literally everybody that has a piece of the puzzle to get the performance that your customer's wanting out of this spacecraft. And so you have to be the one to help deliver on the evidence that those things are working the way they are supposed to. So that falls into the next skill that I think is super important, is communication and teamwork. This one is a struggle for me. Starting my engineering career, I wasn't really someone that liked to talk a lot. In fact, I started in design and I really enjoyed being able to kind of plug away at tinkering on drawings and putting some really simple models together and sort of huddling into my own little narrow hole of work. Operating in this job is very much so the opposite of it. There's a joke that a good systems engineer is one that is talking all the time. And to be honest with you, I think that's where the systems piece comes into my title, which is you've got to be able to communicate with everybody at all times, whether you're giving updates or you're giving direction or you're asking for help from many different levels. You have to be able to have the confidence to speak up about things that you may be dealing with, whether it's an easy conversation or a hard one. Typically it's a hard one because a lot of times things just don't go right and you have to be the bearer of bad news to say, look, we got a problem, but we also got to fix it. So help me find the right people, which very much so lends itself to the teamwork piece, which is there is so much that has to be done every day that you really cannot do alone. Again, that's been a hard thing for me because I've enjoyed having my own tasks and being able to do my own thing, but there is so much that you just have to rely on your team and the other people around you for. Something else, attention to detail. Very small things can make very big problems on the test floor, and it's really up to the test engineers who are there and they are walking around and they are interfacing with the hardware all day to try and notice all the small things that could be going wrong. Whether that's noticing that there's like one bolt loose on a certain payload component, or it's seeing something weird come back during some electrical testing and investigating it and kind of trusting your gut to know like what that seemed a little weird and trying to figure out why it was a little weird. It's very important to try to always be investigating what's going on and not getting too relaxed with everything you're doing on a daily basis. Another one, you got to be comfortable with ambiguity and learning how to problem solve. So a lot of what I do, month after month is changing all the time. There are constantly things that I'm having to figure out and learn that I'm just not comfortable with. And that is, again, something I work on a lot, but I think it is something that everybody on my team has to deal with. Is we get tossed very obscure problems over the fence because we aren't a very big team, and it's on us to try and figure out how to solve those problems. And again, you have people that you can rely on, but at first glance, a lot of times you get put into positions where you are dealing with a problem or some kind of anomaly on the floor or really wherever that you just weren't prepared for, and there's no amount of schooling that typically can get you ready for that. But you got to be comfortable with working hard to solve the problem and looking for as many solutions as you possibly can, which is kind of ironically leading into the last thing, which is knowing how to work to instructions, but also knowing how to think critically. You know, again, a large part of our job is translating requirements into workable either procedures or work instructions, but they don't always go right. So you got to know the difference between when you are marching toward the overarching goal of building a good product versus when you are just blindly following instruction that may be potentially about to cause harm to either you or the personnel around you. So you have to always be ready, whatever critical thinking skills you can, to your projects that you work on daily. What are some of the cool things you see when you work in integration and test? Well, for me personally, I think a lot of the more rigorous testing is very enjoyable to watch. You have vibration testing where you test the dynamics of your vehicle's structure and components to make sure that you're recreating the launch environment for your vehicle and ensuring that everything is going to survive before it gets into its orbital path. Another cool one is thermal vacuum. So you're pumping down in a pressurized vessel and then ramping up and down to specified temperatures for your test profile, and then running health checks and other types of comm tests or specific tests on your vehicle to make sure it's still performing at the same functionality as if it was around maybe orbiting the Earth and going through crazy changes in temperature profiles, or internally if it's having to shed a lot of heat from whatever payload's trying to perform at different phases of its mission operations, and you're just making sure it can withstand all of that. Another one that I think is really cool are things called deployments. So most vehicles have something on them that need to move. Satellites are a really simple example of this. They typically have solar arrays that need to pop out. They have antennas that need to rotate around and gimbal and go through full range of motion, functionality check, and really anything that can go through some kind of actuated testing on the ground to get you a little closer to testing the way that you would fly. And then again, the last piece that I think is really cool is when you get to participate in a launch campaign. So that involves going out to your launch provider. They will have processing facilities where you and your team get a set duration of time to get your vehicles in, and you work with your launch provider to make sure that you're cabling up appropriately, all of your interfaces are working correctly, and you are handing it off to their team to then get to the launch pad, which is a really, really cool feat. Now, this last piece, I just want to talk about the reward of getting to be in a position like this. You know, it's just like anything over time, it sort of loses its shimmer a little bit when you've been doing it every single day. But time and time again, I catch myself just being involved with something on the floor and being around people that are just amazing. And I wanted to talk about those things because I think these are the hidden gems of this sort of weird world of folks that have worked on spacecraft for, you know, years and a long time since aerospace became a big deal. I just think there's a lot of cool things to be said about what you get to see. So one of them is actually seeing something like a spacecraft come together. It's crazy when it starts out as this model or this drawing that you look at for a very long time and you give feedback on how you're going to put it together, and then actually seeing it come to life is a very cool and exciting experience every single time. Something else really cool, at times it's stressful, but it's also a very humbling feeling to, in a sense, be the last line of defense prior to getting to launch. So there is so much riding on the AI&T teams to get stuff done and delivered out the door to the customer. You know, it's coming to the end of really everything that your company has been working on for a long time, and you are the ones to try and get that delivered and to make sure that it's performing at the level that is expected for your customer. So I'll say it's very high responsibility, but it's also very high impact what you're doing on a daily basis. Something else really cool is the team camaraderie. Something very unique about the team that I'm a part of, and I think what a lot of teams are a part of. You get very close with the people around you because you're put under a lot of pressure, and you all have to learn how to coordinate and cooperate with each other, more so I would argue than most engineering teams have to. You spend very long hours, weekends, you're exhausted typically, and you're trying to do stressful stuff. And that's when like the real human side of everybody comes out, and you tend to bond pretty deeply with people that you work with, which has been awesome. And I've met and have become friends with a lot of incredible human beings because of that. The last one, the thing that I love to talk about the most, is the wow factor of getting to touch space hardware. That is like my number one thing that I say I have loved about this job, and I would argue a lot of people love about this job, is actually being someone that gets to say you put your hands on hardware that is in space right now. This is something I didn't fully understand getting out of engineering school, but it really makes sense. There's a lot of teams that design something, or they'll spend years of their life putting a bunch of effort into designing or creating something, and oftentimes they never get the chance to actually go touch it and interface with it. They don't get to run tests on it. They may not get to turn a wrench to put pieces of it together. Whereas our team is the complete opposite, where that is literally the day-to-day operation, is making sure that you are interfacing with the hardware and putting it together and getting it to work and getting it shipped out the door, which is just incredibly exciting. And again, very humbling, because it is a lot of effort put in by a lot of teams that you are helping get through the finish line. To kind of wrap this thing up, please throw some comments down below if you have questions for me that I can try to answer about my experience, or if you want some resources or just any further information about videos like this. I'm really curious to know if stuff like this is important for people to hear about or talk about or even think about, because it meant a lot to me getting into this role, not knowing much and not finding a lot of information about it. So I would just like to do the best that I can to convey like, hey, this is what's going on in my world. And I'm also curious like what other people's experiences have been like that are working either in integration and test or some variation of production that just goes on kind of in the dark behind closed doors and keeps the world of production moving. And look forward to hearing from you. Thanks, everybody.